Hey coding buds, so basically today's GFG POTD we have a problem assign mice holes, and it is an easy level problem. And as the problem statement is given as you are given two arrays mices and holes of the same size. The array mices represents the positions of the mice on the straight line, while the array holes represents the positions of the holes on the same line, which each holes can accommodate exactly one mouse. A mouse can either stay in its current position, move one step to its right, or move one step to its left, and each move takes 1 minute. The task is to assign each mouse to be distinct holes in such a way that the time taken by the last mouse to reach its hole is minimized. Okay, so in the given problem we have an array of mice as well as an array of holes, and we have like already declared here that a mouse is having at least one distinct holes. Like for each mice we have each holes. Okay, and we have to give the we have to like define what we have to define, like the times which take by mice to reach at their hole, and like it is taking 1 minute. Okay, as it is saying that on each step, or we can say it on one steps from left or to right, each move takes 1 minute. Okay, so let's understand by the example here. So here we have mice, let's say 4 minus 4 and 2. Okay, so these are like we can say it positions of the, okay, assign the mouse at position 4 to the hole at position 4. Okay, so these are the position of mouses. Okay, like 4 4 and 4 minus 4 and 2, and these are the positions of we can set holes, and we need to assign each mouse to each holes. Okay, and then after that here we have to return the maximum time required by the mouse. Okay, like which mouse is taking maximum time. So in that case how we can solve it? See, let's try to understand this by using some example here. Okay, but before that, here is the second example here where we have two mouse, let's say 1 2, and holes are like 20 and 10. And if we are like assigning our first mouse to the position 10 and second mouse to 20, then the time it will take like around 18 minutes. Okay, so how we have like solved this problem? So according to this, here it is saying that assign the mouse at position 1 to the position 10, so the time it takes is like 9 minutes. Okay, because it is like on each step it is taking 1 minute. Okay, so it is taking 9 minutes, and after the position 2, after the assigning the mouse at position 2, the hole is at position 20, so the time it takes around 18 minutes. Hence the maximum time required by any mouse is like 18 minutes. So what we actually doing here, we are just simply subtracting the hole's distance minus the mouse position. Okay, so this is the basic position. Okay, that means position of mouse is like 1, and here it is position of mouse is like 2. So here we just here it is simply calculate the maximum length of the positions of holes as well as the mices. Okay, so here the constant is given like mices dot size must be like greater than or equal to 1 and less than or equal to 10 to the power 5. Okay, and here we have to solve this problem with an expected time complexity of order of n log n, and the expected auxiliary space of like order of 1, and it is completely based on mathematical algorithms and greedy and sorting. Okay, so let's try to solve this problem here. So here let's see if I'm talking about by the example here. Here we have let's say 4 minus 4 and 2. So let's say these are the mouses here which I have drawn here. So please don't go on my drawing, just try to understand this problem here. Let's say it is at positions minus 4. So let's say this is mouse 1, and minus 4 4 and 2. Okay, let's say here it is, let's say 4 minus 4 and then 2. Okay, and also we have the distance, or we can say that also we have positions of like holes also. So it is like 405. Okay, so let's say it is having 405. Okay, 405, and by the explanation we can understand it here, like assign the mouse at position 4 to the hole at position 4. So we have to assign this mouse to this position, and we know each mouse can take only each holes. Okay, similarly if I'm talking about the second here, so here our second, which is like mouse at position -4, we have to point it to 0. Okay, let's say we actually pointing to its this hole, and at the last we actually pointing to this. So if we are actually going to calculate the maximum minute, okay, or the maximum time taken by the mouse is like 4 minutes by this example here. Okay, but how we can actually get it? We have to just simply do what? We have to just find the absolute differences between the mouse and the holes. Okay, so let's say if I'm saying that 4 minus 4, so we're actually getting 0. Okay, in this case we are actually getting 0. That means this mouse is taking 0 minute. Okay, and similarly if I'm talking about this, so here it is near to this mouse. Okay, so it is not taking any time, it is also like somewhere taking -4 second, or yeah, like that. Okay, -4, not -4 second, -4 minute. Okay, so it is like too faster. Okay, but if I'm talking about this third mouse, so it is like far away from this mouse, as here the distance or the position for this one is like 6 minutes from this mouse. Okay, and this is at position 2. So for reaching this mouse to this holes, it is almost taking 4 minutes. Okay, so it is the maximum time which we actually getting here. Okay, because they are like near to the holes. Okay, here it is also taking no time, because it is like just standing outside the hole. We can say that here this is also just standing outside the hole, but this is like far away from the hole, so it is like taking almost 4 minutes to reach at their holes. So this is the maximum time. Okay, similarly if I'm talking about the second example here, so here we have like 1 and 2. So here to just simply calculate the we can say that absolute differences here. Okay, so let's say for 1 I'm assigning to 10, so 10 minus 1, that means 9. It will take 9 minutes. Okay, similarly if I'm talking about the second mouse, which is at position 2, so if I'm like finding the absolute differences between the holes and the second mouse, so it will be like 18 minutes. So here output will be like 18 minutes, because here we have to return the maximum time taken by the mouse. Okay, so let's try to solve this problem. But if I'm going to talk here in the second example here, so here we are actually assigning 1 to mouse 1 to, we can say that mouse which is at position 1, we are assigning to the holes which is at position 10. So what we actually doing here, we actually doing sorting first. Okay, that means we are actually providing first mouse to our first mouse to the first hole. Okay, so for that here we are just simply doing sort mices dot begin and mices dot end. Okay, so here we performed our inbuilt sorting method. Okay, for mices. Okay, once our mices will sort, we need to also sort our holes also. So here we can say that holes dot begin and holes dot end. Once you performed holes dot end, once you performed sorting, then we actually getting for the mouse which is like pointing at position 1 is like pointed to 10, and the mouse which is at position 2 is pointing to position 20. Okay, so after performing this we can say sorting algorithm, we are actually defining the mouses for each distinct holes also. Okay, now once you have done these things, now we have to traverse and assign the uh, holes for each mouse. Okay, so here for int I is equal to 0 and I is less than mice's size, because both of them are like having same sizes, mice's as well as holes, and they all are like having distinct like each mouse is having distinct holes. Okay, so mice's dot size, and then after that here to I plus plus, that means we have to traverse till all the mouses size. Okay, and then after that here before that we have to also like declare our answer variable int answer, which where we have to just initialize it with 0. Okay, where we have to put our final value, like how much time it will take, maximum time to reach at the hole. Okay, so for that here we have to uh, we can say that here we have to update our answer with the maximum time taken by the mouse to reach at holes. Okay, so answer is equal to, here to find maximum time, so we have to use max function, and inside max function we have to take either answer variable, or we have to find absolute value of holes of I. Okay, that means for I holes, okay, minus mices of I. Okay, that means we have to find the absolute difference, and those who are having maximum value we have to just simply store it into our answer variable, and just at the last we have to simply return our answer variable. Let's try to compile and run. So here compilation is completed. Let's try to submit it. So it's submitted. So yeah, that's all for today. Thanks for watching.